What's up, guys? Andrew Kramer here in our second lesson on the FBX workflow. And today we're going to be copying the buildings to points, learning how to instance them in Redshift as RS proxies, and shading them as well. So let's jump right in. We're starting where we left off yesterday, and what I want to do is I need to add a couple more nodes onto the ends of these, namely a scale, which will be a transform. I'm going to set this pretty low. And I'm also going to do a null called out that we can reference. So I'm just going to do Control X to cut it and paste it like we did last lesson on the ends. And now we have 19 outs, 19 buildings. So next up, we've got to create some points to copy these to. So let's create a grid. And I'm going to set this to 20.5. And I'm going to do a point from volume. You can use a scatter. You can do whatever you want. And there we have our grid of points. I'm going to set this to 2.5 and tetrahedral. And then what I'm going to do is I'm going to throw down a sort, which is going to randomize the point number. See? So now that we've done that, I want to randomly orientate these. Well, not randomly orientate. I want to basically spin these 180 randomly. So like, for example, this one could be minus 90, this one could be plus 90, this one could be 180. So that's what I'm trying to do. And the easiest way I found to do that is with a for each feedback. And the reason for that is that in here, basically, we can set this to run a certain number of times. And what I'm going to do is I'm going to put down a group by range. And if I select the render flags on this and go to points, hide our point number visualization, I'm going to do this out of 4 because we can spin this, 180 degrees randomly. So, and basically on each iteration, I want this offset to go up by 1, like this. But first off, I'm going to copy the number that we have here and put this into our iterations. So now we have 4 in here. And the way that we get the iteration that we're on is we create a meta import node. And the way I reference this is just by going, it's a detail attribute. So if I go up here, you see detail attributes, iteration. So if I go in here, I can do detail, put the node name in here. So repeat begin metadata, close that. And then we need the attribute, which is iteration, followed by the index, which is 0 because it's a float. So now we have our iteration, I believe. So yeah, if you see a number higher than 1, then you've smashed it and it works. And then we need to orientate these. So put this down here and select our point group, which is group 1. Could have named it a bit better, but hey ho. And then we need to use our orient function. So in here, I'm going to create a vector called rotation. And this is going to be on the y-axis. And then I'm going to be multiplying this by radians because we like degrees over here. And I'm going to be using a channel function or a channel that I'm going to call rotation. And close that out. I think we need another bracket in there. So just enable that. And then I'm going to set this to 90. So this is only going to rotate at 90 degrees, so we need our iteration again. So if I go in here and grab this, I want to times this by our iteration. So it'll go up to 270. And then what we need to do is put our orient down here. So at orient equals that thing I can't say. and our vector, which is rotation. Close that out with a semicolon. And then if we go into our geometry spreadsheet, we should see that on the Y, some of them are a different degree of spin, which is what we want. Perfect. So now that we've done that, we can test this out by putting or copying our buildings to this. So if I just move this up a little bit, select the bottom one, and then I'm going to do a compiled for loop of 19 because we have 19 buildings to copy. I'm going to set the inputs now. I'm going to type in here out, accept, and we just wait. So there we go. We've got some buildings looking good. They're random, very nice. And basically what I'm using in here, if you're not using my tools, I'm basically just taking the a random point number, which we've already randomized. We don't even need this random part. And then I'm basically just doing the, that function that I showed in that Vex tutorial. Basically when it reaches the number of buildings, it will go back to 0, so we won't access any of these, anything in here that doesn't exist basically. So we've got 19 in here. Cool. So that's looking good. Obviously you probably need to tweak it and stuff if you're doing this for the first time, but since I've already done this, that's looking fine already. I'll show you what that orient stuff is doing. So there you go. Turn that back on there. So now what I'm going to do is I'm actually going to open Redshift for the first time in this series. So exciting. Bet you can't wait. So we're going to lay out a couple of things first. I'm going to put down a grid. Just put it at a ridiculous size. This is going to be our ground. And then I'm going to put down a camera. Let's say, where are we? Maybe here or something. Let's go with a more interesting side. That one's quite interesting. So somewhere like this. So just control click on your camera and you'll get it in the position that you're currently in. Let's just change some of these parameters. Move it up a little bit. Move in. Looking nice. Cool. Just gonna save this now. And now let's go and mess with some of our shaders. So one of the things I want to do is I'm going to go inside here and I'm going to create a random attribute. Let's call it I at rand, very creative, equals at ptnum. And we're going to basically, what I said in the first tutorial is that I want to create like a sort of, Balamori looking colorful shader. So I'm going to have 4 colors in here. So every time this reaches 4, it'll go back. So basically we're going to be able to create a random color on each of these. And the way that we access this is inside our shader. So I'm going to create a quick mark here. So quick mark 1, I'm going to create a quick mark in our materials, which is going to be 2. And I have my mat over here. So I'm going to create the building shader first. So put down a Redshift material, drag this into your surface, and then I'm going to import an integer. So rs integer user data. You can import points, point attributes, whatever you want. And we need rand. So basically this is going to control our random color. So drop down a shader switch. And then here it allows you to switch between shaders. So if we drag our integer into our selector, and then we can go and put in a couple colors in here. So maybe some pastel-y colors. Something like this. I think I have 4. We'll see in a minute. Something like that should look nice. Just drag that into your diffuse color. And then I'm going to go and do the window material, which naturally is a glass. So we can go through our presets like glass. It's just going to turn our IOR to 1.51 and our transmission up to 1, which is our specular. So now we go back, save, go and drop down a Redshift custom because we don't even need the IPR. The difference between these two is that render will create an IPR, which I never use. I always use a render view. But if you're an IPR kind of person, just drop down the render one. So now I'm gonna go turn on global illumination, so we get some nice, realistic, light bouncing against all these buildings. And I'm gonna create a sunlight, which, since we're at the wrong angle, is gonna be incorrect. Well, it's gonna be very dark. So I'm going to rotate it up a little bit. I'm going to click M to change the orientation of the handle. I'm going to get some nice shadows going along here. And then I'm actually going to stop being blind and look at the render view. So as you can see, I've already done this. And then just click play. And there we go. We've got our random colors, everything going on, looking quite cool. I know I don't have a supercomputer, I just cut in the video, but I'm going to be showing you how to get this to load way faster. I'm going to drop something on the, actually we'll leave it shiny, let's leave it shiny. I want to rotate up a little bit and zoom in. And if you want to go and move around your scene without having to be inside the camera, you can go camera refresh mode, any perspective, and we can go up here and see, look, we've got our roof things, which we created yesterday, if you're using the same kit bash, obviously. But I want to, you can go in here and do whatever you want. You can go and make them blinged out like I'm doing. And now what I'm going to be doing is making this an RS proxy, so this basically loads instantly, or close to instantly, and I'm going to be showing you how to get the full control of your materials changing and all that. So let's go ahead and start on that. So let's close this down. So first off, what we need to do is jump into our copy to points area, and basically what I'm going to be doing is taking every single one of these and putting them into a switch. So just tab, switch, and I'll put it all into here. And then I'm going to do $F -1. So since we're starting on frame 0, or frame 1, sorry, we'll get building 0. And let's just move this out so we can preview this. So as you can see, it's just switching between every single building until it gets to the end. So yeah, the last frame is 19. What you can do to export a proxy is you can either use the Redshift SOP Proxy Export, which is inside your SOP level. I've not had much success with this. It's worked once for me, and then when I tried to export it again, it basically broke everything. So I really don't like using this method, at least in this version. It seems broken to me. So I'm going to put it out here, just, for no reason. And the way I'm going to be doing it is with a ROP. So this is our render ROP, and then we're going to create another one called Proxy Export. Now this is purely a ROP to export proxies. And how do I do that inside this ROP? So what I need to do is find your buildings node, which I've not named, and I'm going to go into the archive, enable RS proxy file, and then I'm going to do proxy tutorial, and then I'm going to put the file name in here. We're going to be using $F to define a unique name, basically, and then put in the file name, or the file extension, which is RS. I'm going to leave all of this blank, and the way that you basically just solo these buildings is you go into Object, and in here, this is sort of a really great thing that is implemented in Mantra, Redshift, Arnold, and essentially what this allows you to do is solo objects and exclude objects in ROPs, so you don't have, you know, a really slow previewing scene. You can just, you know, have it all high quality when you send it to the render view, and you have to remember to switch things on and off. So let's run through this quickly. So candidate objects, basically, if I hover over this, will it tell me? No. So candidate objects essentially means that any objects that are visible in your scene will be visible here. So the reason there's an asterisk here is that it will look through all your scene, and if any object is visible, it will be visible in your render view. If it's turned off, it will be turned off in your render view. Same for lights, but I don't want any lights to be exported in this proxy, and I also don't want all objects that are visible to be exported. I only want to force on this buildings object, which is merge. You can also select it in here. So force objects does what it says. It basically forces the object to appear even if it's off in your scene. So this is really useful later down the line. So if you export something and it's turned off and you're like, oh my god, where's everything gone? That's the reason. So force basically allows you to not make that mistake. So we'll go to archive now, and just change the frame range to go to 19. Is it 19? I think it's 19. Yep, so basically all we have to do now is render the disk, and we'll get a little Houdini dialog exporting these RS files, which are really tiny, by the way. They're like 11 kilobytes. And then what we're going to need to do is instance these. So if I go over to my proxy, actually we'll get the file name later. We've got some stuff to do first. So if I go inside the merge, I need to get these points. Nothing else, just these points. So what I'm going to do is I don't want this attribute wrangle. I just want to, you know, create a null instance point out. I'm going to copy this. I'm going to go up and I'm going to put down an instance node. In Redshift, you don't actually need to use an instance node. You can use a geo node, but you know, this is sort of the correct way to do it. I'm going to go to instance and fastpoint instancing to start off with. Arnold, as far as I'm aware, only supports fastpoint instancing for some reason. It's kind of weird. But Redshift is fine with everything. If I turn off this, because we don't need it anymore, if I go in here, there's going to be a single point in here, and I'm going to put down an object merge. And since we copied that object, we can actually paste the path in here, which is really useful. And then, you know, if you've added any external transforms, you can do into this object, and it won't, you know, if you've added any transforms to geo level, aka this level, they will be brought over into your object merge, but I haven't. So now we need to write down some code to instance these. If you only have a single object, you can actually just go into the instance object and select your object in here. But my scene's already a bit crowded, so I don't even want to be bringing these RS proxies into the scene. By the way, if you want to do it quickly, you can go up here and use my tool. Just bring in whatever proxies you want quickly. And the way that these are set up is it just adds it into this proxy file name. That's how you import a proxy. And as you can see, you've got sort of a low detail bounding box of your object. But we're going to be doing it a fancy way, referencing the actual file on your drive. So if we go in here, we call this instance buildings. I want to still create my rand attribute because as I said, I want to access these attributes and control the materials, even though I've actually baked these materials into the proxy. It's confusing, I know. So I'm going to recreate that attribute that we created. And then underneath this, we're going to do s at instance. S defines a string. And then I'm going to go and get my path, which is in my ROP. So cool little tip is if you middle click here, you'll get your expanded path. Just watch out if it's $F, it will give you the frame. So I'm going to copy up until just before 1 because we need to iterate this randomly. So if I go drop this in here, we'll put a quotation first. It can be double or single. And then I'm going to close this, and then I'm going to add basically a random number to this. I'm going to get the same one that I had in here. So if we go and copy this code, we can just set this to 250. So we're going to get a random float here. If you don't care about keeping the same, pattern as you had before, you can obviously just do whatever. But I'm going to go and bring in the actual pattern. So if I put in this in here, and then we do int rand equals, this is kind of dangerous that we're creating similar name stuff. Call it switch instead. So switch rand, and then we're going to do our repeat after a certain number, so it'll be 19. And we need to add this to our string, but since it's an integer, the Vex won't like it basically. So what we need to do is we need to do plus itoa, which is going to change this to a string basically. It's like doing repr or str in Python if you're a Python guy. And then we put in our integer, which is switch. Maybe we should call it switch 2 because we've already defined a float. And then I'm going to add .rs to the end of this and close it out with a semicolon. So now if I go into my geometry spreadsheet, let's check that this path exists. So as you can see, we're getting a random value for each one of our points. It's exactly what we want. I'm pretty sure this path is fine. So now that we've done that, this should all be working fine. I'm going to save this first. And then we're going to go back to GeoLevel and render this. Oh no. I made a fatal error, guys. This is going to change everything. I forgot to add file to the end of this. Basically, if you do s at instance, then you can reference things inside your scene. S at instance file references stuff on your drive. So we'll go back now. Let's try this again. And there we have it. That took way less time on my computer to export, which is good news. The bad news is that we've lost our random attribute, which kind of sucks. And the reason for this is that there's a couple things that we need to turn on inside our Redshift tag, which isn't automatically here. So if I go and hover over our scene view and type obj, we get our object parameters for Redshift. I can go over to our proxy and enable override user data. And then if I export this again, there we've got our attribute back. And then what if I want to go and edit this? So let's say, I decided I want to change this to a fucking metal texture. It's not going to change. And the reason for that is that proxies can bake textures, which is what I've done. But to actually disable this, you have to go over to your instance tab. And then what we've got to do is override instance file proxy materials. And then that allows us to use our scene materials instead of the ones inside here. So there we have it. Now we've got some amazing gold structures from Dubai. And now we have the classic milky coffee texture. Truly a classic. So yeah, this tutorial's ran on far enough, but I packed quite a lot of information into this. Any questions, drop them in the comments, and yeah, hope you enjoyed, and I'll see you in the next one.